Hello and welcome to Lesson 8.5. Today we're going to look at division properties of exponents. So ultimately we're going to be looking at dividing powers that have the same base and raising a quotient to a power. So to start off with a little review, for number 1 here it says x squared times x to the 5th. So if you recall, when you have the same bases and you're multiplying, we are actually going to make that x to the 2 plus 5, which is equal to x to the 7th. Just like in this number 2, again, I'm multiplying when I have the same bases. Therefore, I'm going to add my exponents. So this gives me r to the 3 plus 0 plus a negative 1, or r to the second power. For number 3, I have a power being raised to a power. So because I have a power being raised to the power, my base stays the same, and then we just end up multiplying the exponents. So I end up with t to the 8th power. And that would be very similar to number 4, where I have a power being raised to a power. Here I have to multiply my exponents. So I have m to the negative 3rd. But then because I have that negative exponent, I need to correct that, and that really becomes 1 divided by m to the 3rd power. So this is a quick review on multiplication. Now, when we get down here to the bottom, it says, what happens if you are given x to the 7th divided by x squared? Well, if you remember, x to the 7th is really x times x times x times x times x times x times x, all divided by x squared, which is just x times x. So if I go to simplify this, I have an x on the top and an x on the bottom, so those are going to cancel. I have another x on the top and an x on the bottom, and then what that does is that gives me 5 x's being multiplied by each other, or x to the 5th. So if I look at my relationship between my exponents on this quotient here, that's really the same thing as saying x to the 7 minus 2, which gives me x to the 5th. So when you divide and you have the same base and you're dividing and they have exponents, then we're going to subtract our exponents, and it's always the top exponent minus the bottom exponent. So again, just to reiterate with an actual definition, it says for every non-zero number a and integers m and n, a to the power of m divided by a to the power of n equals a to the m minus n. Again, you are subtracting the top exponent by the bottom exponent. So let's go ahead and do a little bit of practice. So for part A on example 1, I really end up with b to the 4 minus 9. Well, 4 minus 9 is a negative 5, so that gives me b to the negative 5th, and I can't have a negative exponent, so I'm going to simplify this as 1 divided by b to the 5th. And this here would then be my final answer. For part B, I have z to the 10th divided by z to the 5th. So this is going to be z to the 10 minus 5, or z to the 5th. Likewise, for part C, now this one's a little more complex, but I'm going to treat it the same. First, I'm going to look at the a terms. So a to the 2 minus 4 times b to the, remember this is really b to the 1st divided by b to the 3rd, so that would be 1 minus 3. So when I simplify that, that's a to the negative 2nd, b to the negative 2nd, and I need to get rid of both of my negative exponents, so that really becomes 1 divided by a squared, b squared, and this is my final answer. And then for part D, I'm going to do the exact same thing where I'm going to address the like terms. So I have m to the negative 1 minus 3 times n to the 2 minus 1, because remember that's really a 1 there. So when I simplify, negative 1 minus 3 is really a negative 4, and then 2 minus 1 is really 1. So in this case, you only have one negative exponent, and that's m. So n can go ahead and stay in the numerator, and I'm going to move m to the 4th down to the bottom, and this is my final answer. And just like with multiplication, we also are going to have the situations where we're going to take a quotient or like a fraction and raise that to a power. So it's really no different. The only thing you have to remember to do is distribute that exponent onto both the numerator and the denominator. So if we read through the definition, it says for every non-zero number a and b and integer n, the fraction a divided by b raised to the nth power is equal to a to the n divided by b to the n. So again, if you notice, they distributed that n onto both the numerator and the denominator. So for example 2, we have 3 squared divided by x, 3 divided by x squared, and that whole thing is going to be squared. So the first thing we're going to do is we are going to distribute that 2 onto both of these, the numerator and the denominator. So that gives me 3 squared divided by, well, x squared raised to the second power is a power to a power, so 2 times 2 is 4. So I end up with 3 squared divided by x to the 4th, and if I simplify 3 squared, that's 9 divided by x to the 4th. And this is as far as I can take that. For the second part, I'm going to do the exact same thing. I'm going to distribute that 3 to both the x and the y squared. So now I have x cubed divided by y, and again, a power to a power, I multiply. So 2 times 3 then is going to give me 6. And I cannot simplify that any farther, so I'm just going to go ahead and leave it just like this. Now, example 3 might look a little more complex than the first or previous examples, but it's really not that bad. We're going to follow the exact same steps. So here I have a quantity that's being raised to the power, so I'm going to distribute that power onto everything, so that gives me 2 to the 5th. Then I have a to the 3 times 5, or a to the 15th, and then I have to multiply b to the negative 2nd raised to the 5th power, so that gives me b to the negative 10th. And then I also have to distribute that 5 onto the denominator, which is going to give me c to the 15th. So the only thing that I need to do is I just need to simplify numbers and any negative exponents. Well, 2 to the 5th is 32. So I have 32a to the 15th. This b here is raised to the negative power, so I'm going to make that move right now. So I end up with b to the 10th on the bottom. And then I also have that c to the 15th also on the bottom, and I'm going to leave that there. So this is my final answer. And for the last part of example 3, I'm going to follow the exact same process. So here I have a 4. I need to distribute that onto the p. So that gives me p to the negative 12th. I'm going to distribute that onto the q. So now I have q to the negative 8th. Divided by, I'm going to distribute 4 onto the bottom. So here I have q to the negative 12th. And then I distribute that 4 onto the 5, or onto the r. So now I have r to the 20th. Now, when I look at this right away, you can do this in a couple different ways. I personally notice that I have a q in the top and a q in the bottom. So I'm going to address that first. So this gives me p to the negative 12. And remember, I'm going to end up subtracting because I'm dividing. I have q to the negative 8th divided by q to the negative 12. So when I divide, that's really negative 8 minus a negative 12. And I'm going to divide that by r to the 20th. Well, a negative 8 divided by, minus a negative 12 really makes that negative 8 plus 12, which is going to give me a positive 4. So now if I simplify this, I see that my p has to go to the bottom because it has a negative exponent. So I'm going to move that down right now. So I have p to the 12th. My r had a positive exponent, so that's also going to stay down there. And then I really ended up with q to the positive 4th in the top, and this then is my final answer. And for our last example, example 4, I'm going to distribute my negative exponent onto both the numerator and the denominator. So this gives me 3 to the negative 3rd divided by 4 to the negative 3rd. Well, I have two negative exponents, which tells me that they need to switch spots. So that's going to give me 4 to the 3rd divided by 3 to the 3rd. And when I simplify, 4 to the 3rd is really 64, and 3 to the 3rd is really 27. So I end up with 64/27. And this is going to wrap up our last example for today's video. Please let me know if you have any questions. Otherwise, I hope you have a great day, and I will see you in class.